Okay, so both of these are the different way of saying the same thing. Now, what we can also do is to see if we can solve some problems using this. Okay, so I'll come back to talk about this. The positive current flowing into the op amp is 0. There's a virtual short. The voltage applied on the negative terminal is equals to the positive terminal. Okay, so what we will do is to come back and look at, I think I want to stop here. We have um, a very good head start on the op amp chapter. Um, I want to do it a little backwards. Okay, this is a little um, complicated circuit compared to some of the other circuits that we are going to look at later. So this guy, we'll start with this guy. Okay, so all we are doing is think about this, and I'll introduce this in a very um, introductory fashion, and then we can continue from here. The idea is that um, I'm tying one of the inputs to ground. Okay, I'm tying one of the inputs to ground, and I'm applying an input, a VS input, to the inverting terminal. Okay, so what happens is, in this case, the output VO is going to be an amplified version of VS. Not only is it an amplified version, it's an inverted version. So if you think about this guy as your input, if that is your input, which is VS, the output is going to be an amplified and an inverted version of it. Okay, so this is the output, which is VO. Okay, so this is called an inverting amplifier because the input is not only amplified, but it's also inverted in phase. Okay, so the input sine wave is inverted. The sign of that input is okay, opposite to that of the input. Okay, so if you do the analysis, so on and so forth, that exactly what is borne out in the example, the out analysis. The output voltage is input times some gain. Okay, if you notice the gain, that has a negative sign, negative RF over RS. Okay, so that's the idea of an inverting amplifier. The output is exactly the inverse of the inverted magnified version of the input. Okay, so here is my input. Okay, the output is going to be a magnified version, but inverted version of the input. Okay, this factor, this ratio of V output over V input, V output over V input, this is called gain, and this is equals to negative RF over RS in this case, where RF is that guy, RS is that guy. Okay, so that's the idea. We'll come back, we'll stop here, and um, I don't want to get ahead of myself too much. This is what you would expect to see in the next class, the inverting amplifier. Okay, there is an inverting amplifier. Then we look at a non-inverting amplifier. Okay, a non-inverting amplifier, which is exact opposite of what we do. We apply an input signal to the positive terminal, and we ground one side of the resistance that is connected to the negative terminal. Okay, so earlier what we did in the inverting amplifier was to apply a positive voltage source over here, a voltage source over there, and connect this guy to ground. Okay, so that's what we did in the inverting amplifier. But in the non-inverting amplifier, we apply the input not to the negative terminal, but to the positive terminal here. The input is applied to the positive terminal. So if you think about it, the output is going to be the input times some gain. Okay, so the gain value itself is this guy. So remember, the gain is positive here. So in other words, if you were to look at the input-output relationship, if this is your input, okay, the output is going to be in phase, but a magnified version, okay, of the input. So this is called a non-inverting amplifier because the output and input are in phase, okay. So there is the output is input multiplied by some gain, okay. So that's the gain. Okay, so that's the idea of a non-inverting amplifier.
Discuss how that gain comes about.
Yes, we can. We'll talk about the derivation in the next class, okay? Because that will be the application of the two properties that we talked about, okay? The first property is Vp equals to Vn. The second property is I positive is I negative. Okay, by applying these two properties carefully, we can see how this gain comes about. That's a very good question. Make sense? So the idea is, I don't want to complicate the discussion too much today. I just want to keep it simple, introductory. If you want to, if you're feeling very curious, what you want to do is notice that there is ground applied here. That will show up over there because that's the idea of virtual ground, virtual short, right? The first property of an ideal op amp that I discussed, if you go back, is to note that Vp equals to Vn, right? So Vp equals to Vn. That's the first principle that I talked about when it comes to op amp. So notice that. So then you have a voltage of 0 because this guy is tied to ground. The second property is that the amount of current going in to this op amp is 0. Okay, the amount of current going in to this op amp is 0. So by applying these two properties, you will see that the current flowing into this node has to leave to this node. Okay, and then applying your very familiar KCL at that node, you can see how the gain is going to come out to be what it is. Okay, so but that's a very good question. That's something I want to talk about tomorrow. The non-inverting amplifier, how does this gain come about? Okay, is something I want to leave as a discussion for tomorrow. Make sense?
Yes, sir. Thank you.
Yes. So we'll stop here. We'll come back and discuss tomorrow. For now, if you have time between now and tomorrow, I encourage you to go back and look at some of these slides and the analysis. Okay. All right. So let me stop there. I'll see you folks tomorrow.
All righty. Have a nice day.
Take care.